Hi, grade 10s. Let's do question 4 of this question paper. The information says the sketch below shows the graph of f of x. Can you see there? X is in the denominator. So that means that's the hyperbola. And g of x is ax squared. So when you have x squared, it's a parabola. Okay, so this is the parabola and this is the hyperbola. Then they say 2 and 0 is the x-intercept of f. Now, f is the hyperbola. So on the hyperbola, do you see there? 2 and 0 is the x-intercept. Okay? 4.1 says, or 4.1.1 says, write down the domain of f. Okay? F is the hyperbola. So to write down the domain of a hyperbola, domain refers to the x values, eh? So with the hyperbola, the domain in grade 10 is always the same thing. X is an element of a real number and x cannot be 0. That's always the domain of a hyperbola in grade 10. So 4.1.2, next question. What is the range of G? So the range of G is a parabola. So if you have a parabola, the turning point, you'll have an x and a y value for your turning point. The range is always y is greater than or equal to the y value of the turning point. So y value of turning point. And if you have a sad face parabola, then y is less than or equal to the y value of your turning point. So we have a smiley face parabola over here. So there's our parabola. We have a smiley face. So if you're looking for the range, we are looking for the turning point, eh? So that point over there. Now, we don't have the equation of the graph because if we had the equation, we could just say, oh, this q over there, that's the y value of the turning point. But we don't have that. So now, okay, so now what I'm going to do is, let me fill in some missing information. So do you see this, the hyperbola over there? This one over here refers to the asymptote of the hyperbola. So that means this line here, do you see this line over here? That line is the asymptote. So that line is y. That line is called y is equal to 1 because this is 1. And the turning point of our parabola is on that line. The turning point, x is always 0 and the y value is 1. So here when I write down the range now, because it's a smiley, y is greater than or equal to, and the y value of my turning point. So let's put in our turning point here. Our turning point is now 0 and 1. So y is greater than or equal to 1. That is the range of the parabola. Okay, 4.2, the next question. 4.2 says, determine the value of b. So let's look, where is b? Okay, b is there by the hyperbola. So let's write our function down, b over x plus 1. So we have to solve this later on top there. So to solve that, we just need a point on the hyperbola. So I'm going to highlight the hyperbola. So it's this side, okay, and this side. So I just need a point. Okay, I can see a point. This x-intercept, that's a point, eh? So let's write down. I'm going to sub 2 and 0 because 2 and 0 is on the hyperbola. So y is 0, x is 2. So 0 is equal to b over 2 plus 1. So I made this y 0 and I made this x 2. Eh? So now I'm going to take the 1 over. So this is 0 minus 1 is b over 2. So this gives me negative 1, b over 2. And then I'm going to cross multiply. Take the 2 over and multiply. So I get this to be negative 2. And this is b. So b is negative 2. There you have the value for b. So the equation of the hyperbola, let's write this down. F of x is negative 2 over x plus 1. Our next question says, 4.3, says determine the equation of g. So we have to determine this equation, eh? So determine the equation of g if the x value at the point of intersection of the two graphs is -1. So do you see this is a point of intersection and that x value there is -1. So that point of intersection, -1, and we don't know what the y value is. Okay, so now they want you to use that to find this equation of the parabola. Let's write 4.3. So to find an equation of a parabola, so to find the equation of a parabola, what do we normally do? First thing we do is we need to look for the turning point. Now, we know what the turning point is. The turning point is 0 and 1. So that q over there is 1. So far, at least we can fill in that. Plus 1. Now to get a, what do we normally do? We sub in a point. So we need to sub in a point on the parabola. So I'm going to highlight the parabola and see if I have a point. So I don't have a point. I don't see any point except the turning point, eh? But I've used the turning point already, so I need another point. This point of intersection, I have, but the problem is I only have the x value. I don't have the y value. So, and I need the x and the y value. So what I'm going to do is I am going to say that this point is on the hyperbola as well. So I'm going to write the equation of the hyperbola down. So this is the equation of the hyperbola. And then I'm going to sub in that x is equal to -1. So let's go, just sub in that x is -1. And then I'm going to try and see what do I get the y value to be at that point. So this will give me a +2 plus 1, which is 3. So the y value at that point is 3. There, I worked it out. So now I can sub in a point on the parabola because that point is on the hyperbola, but it is also on the parabola. So I'm going to sub in 1, -1, and 3. Okay, let me wrap this up. Okay, you don't wrap that out there. You show all your work. So now I'm going to sub in. This is now the x and that's the y. So y becomes 3. X becomes -1 plus 1. Okay, so this is 3. This is just 1 plus 1. 3, 1a plus 1. A is 3 minus 1. A is 2. So there I have a. So I put this a back here. So the equation of g of x is 2x squared plus 1. And that's the equation of the parabola. Okay, our next question is 4.4. 4.4 says, write down the equation of the line of symmetry, so the axis of symmetry, which has a negative gradient. Let's write 4.4. So the equation of the line of symmetry with a negative gradient is always y is equal to -x. And then plus or minus the asymptote. Our asymptote was +1. So here you're going to write +1. And that's the answer. If it was a positive gradient, you write that down and then plus or minus the asymptote, +1. And there you have 2 marks for that, eh? Okay, our next question. For which values of x is g of x decreasing? So when is g of x decreasing? G of x is the parabola. So if I go from left to right, from here to here, it's going down. So that's decreasing. And then after the turning point, from here to here, it goes up. So the yellow part is where it is decreasing, eh? So 4.5.1. What is the x value here at the turning point? Because that is when the direction changes. The x value there is 0 because that's the turning point. So if you have 0, we can ask ourselves, what happens before 0? It's decreasing. What happens after 0? It's increasing. So now the question is, for which values of x is this function decreasing? Increasing and decreasing is always an open dot. So it's this side of 0. So we write it's where x is less than 0. That's the answer there. Then the next question is, for which values of x is f of x greater than g of x? So remember I told you, f of x greater than g of x, points of intersection. So there's only one point of intersection here. It's this one here. And the x value is -1. But because there's a hyperbola involved, we also include the asymptote as a critical point. So there is our asymptote, the vertical asymptote. So on a number line, let me do the number line. I'm going to have the x value of the point of intersection, -1, and the x value of the asymptote. X is 0 on this line, eh? So, okay, I'm going to move my finger on f of x because f of x was first. Because f of x was first in the question, eh? So I'm going to move my finger on f. Let's go. So f is the hyperbola. So from, okay, let me just make my point of intersection there. So from here to the point of intersection, the hyperbola is below the parabola. So below. Then let's look from here to the asymptote. So from here to the asymptote, the hyperbola is above. And then after the asymptote, if I go this side, the hyperbola is always below the parabola because there's the parabola. Here you can see it's below the parabola. Eh? So after the asymptote, this was a plus, it's below. So the question is, where is it greater than? Greater than means above. So it's where you have a plus. So I'm going to circle the plus. Our plus is between -1 and 0. So our final answer is, it is where x is between -1 and 0. And there's no equal sign, so we also don't have an equal sign. Look at 4.6. So 4.6 says, calculate the y value when the horizontal distance between the arms of the parabola is 6 units. So with your parabola, if you have a parabola, and the x value here is -1, and the x value is +1, then this distance here is 2 units. Okay, remember? This is now 0. So this is 1. So from here to here is 1 unit. From here to here is 1 unit. So that's 2 units, eh? That's the horizontal distance between those two arms. Okay, now let's do another line. I just want to show you. So let's say 2, eh? Let's say you have -2 and 2. Then from here to here is 2 units. From here to here is 2 units. So in total, 4 units. Okay? But we're not looking for 4. We're looking for 6. So let's say, for example, this is -3 and this is +3. Then from here to here is 3. And from here to here is also 3. And there you have 6 units. So you will have 6 units where x is -3 or where x is +3, eh? But the question is not what's the values of x at this point. So they want to know what's this point. They want to know what's the y value at that point. So to get the y value at that point, I write the equation of my parabola down. And I just sub in this x value. So let's sub in -3. And you will get your y to be 19. So this point over here is actually -3 and 19. And then this point over here, just to make sure, let's sub in a +3. You'll see you get the same answer. This is also 19. So this point over here is 3 and 19. So now the question is, what is the y value? So that y value. What's that y value when this distance is 6 units? So therefore, the y value is 19. Okay, then the last question, 4.7. 4.7 says, write down the equation of k of x if k of x is -g of x plus 3. So let's write that down. K of x is -g of x plus 3. So k of x is negative. Where's g of x? So here's g of x. Let's write that down. That was 2x squared plus 1. That's g of x plus 3. And now we just remove the brackets. This times this, -2x squared. This times this, -1 plus 3. Add the like terms, -2x squared plus 2. And this is the equation of k of x. And there we've done the full question.